Okay, let's review Keynes.
Take a few hours.
All right, one economist that this is Charles Hall, and we're doing our Energy and Economics series, lecture 7. But this is one thing I didn't do in the end of lecture 6, which I think is very important, where we were reviewing many earlier economists and making the point that what is called economics today is only one of many possible approaches to economics that have been done, in fact, in the past. And I've talked about the physiocrats and the the classical and then the neoclassical, which we do now. And I suppose Keynes is considered a neoclassical economist. He's certainly a social scientist and not particularly rooted in what I think is more, well, maybe not more important, but in particularly important in the natural sciences. But Keynes was a very, very smart guy. And the problem that Keynes approached was that if you look at the rate of growth, the change from one year to the next, in this case of GNP, which is the solid line here, you see there was a huge change in economic circumstances, often 15 or 20% change from one year to the next. That's enormous. You know, we get all bent out of shape when we have a change of 5% now, but it was much more in the past, and frequently, and often the growth of the economy would be large or the contraction of the economy would be large. And so this was the issue that Keynes approached.
Share the
And
screen.
what Keynes said basically was that the government, if it's large enough, and he thought it was in England, for example, can step in and greatly reduce economic turmoil, market turmoil, turmoil in people's life of whether they are employed or not. Keynes thought we could change this enormously by the government intervening in the society, and come back here, when the economy was doing poorly, to inject a lot of money, print money, you could say, into the economy, and that would help the economy recover. And the other side of the equation was that when the economy was expanding very rapidly, government expenditures should decrease. Now, in fact, and unfortunately, I don't have a time scale on this, but this particular graph ends about 1970.
Charles,
Share the
can
screen.
73.
share-
This was the graph I was hoping I was showing. And unfortunately, I don't have a time scale on this, but I think it's from about 1900 until about 1975 is the scale here. And the economy used to fluctuate a great deal. And here's zero. This would be no change from one year to the other. The economy grew more often than it contracted during this time period, but the fluctuations were enormous. And Keynes said, if government intervenes in the economy, then we could make the economy a lot smoother, which will make things a lot easier for all kinds of people. And in fact, starting with Franklin Roosevelt, people intervene in the economy more and more. And in fact, we can say that there is empirical evidence that Keynes and the application of Keynesians took out the major fluctuations in the economy. So for many years, people thought Keynes was a solution to economic problems. And it is more frequently the perspective of so-called liberals, so-called leftists, that the government could intervene and should intervene in the economy. And of course, these people's perspectives on this continue to be very pro or very anti, and it's roughly related to Democrats and Republicans, but it's not that simple. And so, I would say that Biden is definitely an interventionist and is spending a lot of money on new types of energy and infrastructure fixing and so forth. And the economy has been, even though it seems like a lot of people don't believe it, the economy by most considerations are doing pretty well now. Okay, so this was Keynes, and as I said, Keynes was a homosexual and put in jail for his perspectives, and that's how we award the people that greatly decreased human suffering in the world. And it's too bad. He was, in my mind, a really great intellectual, but not perfectly, as we shall see. All right, now I'm going to shift to today's lecture. All right, good.
Hey.
All right, now we're going to have in the 7th lecture a critique of neoclassical economics and a argument for the need for a biophysical approach to economics. Okay, let's see there. So for a long time, are we okay now? Everything okay?
Yes, perfect.
For a long time, say 1940 to 1973, neoclassical and Keynesian economics seemed to, quote unquote, work. People tended to be richer each year, and depressions were minor and, quote unquote, cured with government spending. So let's consider some unresolved issues with conventional or neoclassical economics. Now, classical economics goes way back to Adam Smith, Ricardo, Karl Marx, some others. Neoclassical started in about 1880, 1890, and was focused on a social and market perspective on economics. It ignored the importance of land and it continued with some importance of labor, but increasingly considered the importance of capital. And most important, it talked about resolving human wants and needs through markets and through people's decisions in markets. So here are some major problems with conventional economics today. Most important, or let's say, well, most important, and also something that is understood by many economists, is unequal distribution of wealth. The present system we have, which is equated or is hand in glove with capitalism, one might say, have as much wealth as everybody else or more. A failure of the Phillips curve, I'm going to talk about it, what's called secular stagnation, especially in Europe. An explanation, the solo residual, we'll have to talk about that. Inflation, which is, of course, what we're talking about a whole lot now. And externalities, which means things that aren't incorporated in the price of goods and services. These all have a basis in biophysical, meaning biological and physical properties, although maybe that's less, it's not distinctly true for the first issue, unequal distribution. So here we go. Here's the Very often the the distribution of anything, but wealth, for example, is examined through what's called a Gini curve, Gini coefficient, or here's another slightly different way of representing it. This is the distribution over time from 1962 to 2016 of how much of the total wealth the bottom half gets, which is now about 12%. And the top 1% get more than the bottom, get twice as much per capita of the wealth as the bottom 50% of income earners. And almost everybody sees that as a problem, and it's been stated most explicitly perhaps by Thomas Piketty, who are conventional economists. Now, here's another example of a failure of conventional economics. The Phillips curve was a bedrock part of conventional economics in the time of Jimmy Carter as president. And the idea was that there was a trade-off between inflation and unemployment rate. And the idea was if employment was high, i.e. unemployment was low, unemployed workers were scarce, and workers could drive up their wages, and they would contribute to inflation. And so at 3% inflation, they would expect, according to this curve, that inflation might be as high as 9%. Now let's look at where we are today. Today, we're between 3 and 4% unemployment officially, and our inflation is around 4 and a little bit more percent. So we're not quite on that curve, but not too far. But what happened in all of a sudden, I mean, this was bedrock in economics, and this curve was just there in all the textbooks. But then this happened. Here's the curve you see from 1961 to 1969, looking pretty good, and maybe looking not too bad 72 and 71. And then it just went off the charts. Now, no economist could explain this, and they just kind of didn't talk about it mostly. And this is easily explained by a biophysical perspective because the price of oil went through the roof in 1973. And this caused, when the price of oil increases, the price of everything else increases. 73, 74, because everything essentially is made out of oil. And then things calmed down, the price of oil came back down again, but then it went up again. And the inflation went crazy and unemployment increased. This was not supposed to happen in the Phillips curve, but it's easily understood by a biophysical perspective where energy is a particularly important component to society and is something that is external to the operation of the comfortable theories that have been developed based simply on the social sciences. So this is our first example of where biophysical approach, focusing on the importance of the oil supply and even the price of oil, can drive all kinds of economic things in different directions from what people are expecting. And that's one reason that inflation is very difficult to bring down to the 2% that they want now, because the price of oil keeps going up. Okay, secular stagnation, especially in Europe, but everywhere. Now, OECD is the industrial countries, basically US, Japan, and Europe, essentially. And you can see how the growth rate for the world, never mind the fluctuations, but the growth rate in general, from the first oil shock, and then subsequently, the growth rate of the world, which people were expecting to be 5%, no longer does that. And this is not explained by conventional economics, but it's easily explained by, here's the declining growth rate of, for example, the United States. And this is the annual rate of change of the use of petroleum, which used to grow 10% every year, but now has essentially ceased to grow, and it's been almost flat, maybe a little bit of growth since 2010. And so what we see is that something that conventional economics cannot explain is easily explained by understanding the importance of oil supply to growth. This, going back to the growth rate of the economy, this average 5 to 10% growth rate in the past was caused by, or if you wish, allowed by, the rate of growth in the input of our most important product into the economy, oil. But economists pay no special attention to oil or energy as an input to the economy. It's just another commodity. The debt has increased a whole lot, and debt is often blamed on the Democrats, but Reagan, Bush, and Trump made FDR look like pikers. The growth in our debt in the world has increased enormously. This is government debt, and this is government plus private debt, and that's a problem that we haven't dealt with. So it's both a problem by conventional economics and by biophysical economics. Another way that conventional economics fails is by what's called a production function. A Cobb-Douglas production function is the way it's usually stated, in which the quantity of goods and services is a function of only labor and capital. Land used to be into this equation, but that was dropped in the 1950s. Now, when they did this analysis starting in the 1955 and going on for another 20 years, and going on till today, they found that the economy grew about twice as much as could be explained by increases in labor and capital. This is a critical issue that was in economy, in economics, and there were many, many papers written about it, and especially by a guy named Solow. And what they did, because the growth in the economy could not be explained by the increase in labor or the increase in capital, or both of them together, they called this difference Solow's residual. In other words, the economy grew twice as much as the labor and capital input to the economy. And a guy named Dennison wrote 2 books on this, analyzing it in detail. Now, if you ask a physicist or a natural scientist, what's wrong with this equation? They'd say, well, there's no energy in it. You can't produce anything without the use of energy. But that didn't bother the economists. They only thought about capital and labor. I'm not making this up. And so when my friend Reimer, the most important issues were ignored: population growth, depletion, climate change, environmental destruction, and so forth. And I'll come back to that solar residual. The population, look at what the population is doing. Look, I'm born about here. It's increasing unbelievably. Here's just the frequency of the most intense hurricanes, which seems to be increasing. For exactly what reason, we don't know. I can't read what's under there. Why is this? Oh, why is this so? I argue it's the intellectual isolation of economists, and especially its ignorance of and ignoring of the most basic laws of physics. Hardly any economist mentions the main driver of economic growth. It's industrialization. Look at this. Where does wealth come from? This is the BASF factory in Germany. And what is all of this stuff running on? It's running on oil or gas, sometimes coal. And what are they doing? They're generating goods and services. In this case, mostly goods, all the chemicals in your kitchen, and that run our agriculture and everything else. And because it's concentrated in Elizabeth, New Jersey, or in, I guess, Ludwigshafen in Germany or wherever, it's hidden for most of us, or Houston, or the Houston Ship Canal. So if you look at the growth of the world economy, which is the dotted line, and the growth of coal, which is the gray, oil, which is the orange, green, which is natural gas, nuclear is purple, and blue is hydro, and this very little bit here is other wind turbines and so forth. That's become somewhat larger, but it's still only about 5% of all of the energy input. And look at the correlation. It doesn't take a mathematician to figure the two are related, but the economists never talk about it. So just look, we wrote about this, Cleveland and myself and Robert Kaufman and Bob Costanza back in 1984, about the growth of the GNP of the United States and the growth in the use of fuel. And they're almost the same curve. It's remarkable. And even the change from year to year, I showed this graph before. I guess it starts in 1890 and goes to 1980. And this is the reduction of the fluctuations that I attribute to Keynes. So how can the economist ignore this? So we had this, was the cover issue of Science magazine back in 1984. And this just looks at the growth rate of countries that were growing very rapidly during this period. In Korea, for example, or Mexico. The US is maybe not quite such a good example, but as the fuel energy increased, which I consider to be the independent variable, and the dependent variable is the GDP, both of these per capita. And they're very highly correlated. And the US is a special case, not so highly correlated, but we'll talk about that. Certainly some economists recognize the obvious fact that conventional economics was making a huge logical and applied area by not considering energy and resources more explicitly, and in physical, not just price terms. Now, the economists would consider energy and oil in terms of their price, but as in this article about Herman Daly that I just sent and will be available to the class, it's the economists say energy is not important because it's only 5% of the economy. I'm sorry, Economists say energy is not important because it's only 5% of the economy. But I say, and that's measured in dollars, and I'm saying, but energy is important because it is so cheap, not because it isn't more expensive. It's so cheap, and we get so much more punch from energy and pay very little of it, allowing a tremendous surplus that has allowed a whole country and a whole much of the world to become very wealthy. So let's come back to the occasional economist who does understand this. A guy named Leontiev, who got the Nobel Prize in economics and certainly helped the United States win World War II by his so-called IO analysis. In other words, if you needed a landing craft to invade France back in 1941, they're thinking about this, and he thought about, well, if you need a landing craft, you need hoses, and the hose needs brass fittings. Do we have enough brass for and dedicated to building landing boats to do what we need to do? And he often found that people were paying no attention to the brass fittings, but he developed a matrix algebra approach to economics, and that was later done in terms of energy, to figure out what we needed to do to produce each final demand product. But in 1984, he wrote an article in Science magazine, or a letter to Science, and he found economists, quote, unable to advance in any perceptible way a systematic understanding of the operation of a real economic system, unquote. Instead, they were based on, quote, sets of more or less plausible but entirely arbitrary assumptions, leading to precisely stated but irrelevant theoretical conclusions. So here's an economist saying the models of economists made no sense. I'm sure he would be very sympathetic with the perspective that we in biophysical economics have put forth and that I am now developing. He extolled this is Leontiev, he extolled other investigators in demography, sociology, political science, ecology, he said, biology, et cetera, to help remove economics from the splendid isolation in which it is found. And that is what I'm trying to do right now. So let's respond to Leontiev's challenge and try to generate a resolution to these issues. We start with the intellectual isolation of economics. If you take a course in economics, they bring no other human inquiry into it except occasionally human psychology, especially its ignorance of and ignoring of the most basic laws of physics. So our first question is, what is economics? Well, we know the answer from the economists. They say economics is a study of the allocation of scarce resources among competing ends. Well, that might sound like it's making sense. Scarce resources, water, energy, soil, whatever, except resources do not mean what you think. Resources means only money in your wallet. That's what an economist views as resources. This is a social definition of economics. It implies that scarcity is only what's called relative scarcity, that humans are rational, that firms, households, and markets are all you need to make a legitimate economic analysis or understanding. It ignores the first 200 years of economic thinking, where economists thought about land and about factories and so forth. So I don't know if this seems obtuse to you, but these are genuine criticisms that every economist would understand, but probably doesn't write papers about. So tell me the fairy tale about the economy. That's what you get. In the neoclassical world, wealth comes from capital. In the 1970s, Solow dropped even labor. He says wealth comes from capital. And so they come up with this model. This model is seen in chapter 1 of every introductory economics textbook, and they have only two components to the model of how the economy works. There's households and there's firms. And households supply land, labor, and capital to the firms, and firms supply goods and services to households. And the money goes around in the opposite direction. I am not making this up. This is all that there is. There's no environment, there's no resources, there's no energy. It's a perpetual motion machine. And as a natural scientist, we believe that these models of neoclassical economics use incorrect boundaries, are inconsistent with laws of thermodynamics. There's not even any energy in it at all. And is largely based on articles of faith rather than on empirically validated science. So the economics with which your life is ruled by application by government economists and so forth cannot be true because it breaks the laws of physics. The boundaries are incorrect, and it's based on arbitrary, as Leontiev said, perhaps somewhat logical, but arbitrary articles of faith. It's crazy. Reality is different. I put this one in to catch your attention. So here's truth coming out of her well to shame mankind. I just kind of like this thing. This diagram. This is how economies work. It takes resources in the upper part of this diagram and exploits them and makes money, putting certain people to work and making a lot of money for some and a little bit of money for others. And so you see fish and wild animals and wild plants and all going down into this maw of industrialization. And this is not just capitalism. It's true for communism, most other economic isms. They have to exploit nature to generate wealth. Here's another cartoon of how it works. So that here's this big free trade and globalization machine that's sucking up nature and turning it into our consumer stuff, junk it says, and leaving behind environmental destruction. I'm sorry, folks. That's how things work, how the economy works. You spend $1, then half a coffee cup's worth of oil from somewhere about is used and generates pollution and is used to exploit resources, fish or timber or whatever, depending on what you buy, and turned into whatever it is that we consider goods and services. So, for most of my life, I've tried to buy as little as possible. I had to buy a new pair of fishing waders every 2 years for a long time. It's a little harder to live in a marriage with this situation, but that's still the situation. So the cars I have, I do have 2 cars, but they're 20 years old, and we try to drive them not very much. Okay, quite simply, wealth is generated by using fossil energy to exploit the Earth's raw materials and transform them into what we want. To do this, we go through cycles of resource exploitation. And here's what I did. This is actual data for Ecuador. I've studied in 30 different countries, and this is and I've done this kind of analysis for Argentina and Costa Rica and other places, but I thought this was an interesting one. This is data from the United Nations of the economic value of different resources over time. And you see Ecuador went through a series of exploitation of fish, the black line, 2 cycles of exploitation, and then they pretty much wiped them out. Bananas, and then the banana disease, the white spot, not white spot, Cavendish bananas were some kind of a mold or something got a hold of them. The wild, the shrimp pond cultures, then they were destroyed by the white spot disease. The coffee, I don't know why the coffee went down. And then the big one for Ecuador was oil production, but that's now peaked and is on its way down now, and so forth. So this is what happens. It's just a series of resource exploitation cycles. And I got the idea from Ross Toole's analysis of Montana, where Montana went through a series of cycles of first beavers, and then they trapped them out, and then gold, and then used up the gold, silver. Big one was copper, then trees. Oh, eastern dryland farming was in there until that all the soil blew away in 1880. It was just cycles of exploitation, which you can come up with your own for today. It's neither labor nor capital that generates wealth, but nature, and especially the energy used by nature and by humans to exploit nature. But most of today's economics, as Paul Ehrlich said, is not even about money. It's about mathematics. If you read the journals, it's kind of a joke, but anyway. So Paul Krugman is an economist I kind of like, and he says, as I see it, the economics profession went astray. He's talking about the failure of economists to see the crash of the economy in 2008, because economists as a group mistook beauty clad in impressive looking mathematics for truth. This is a very, very nice reference to Keats' Ode on a Grecian Urn, a famous poem. The central cause of the profession's failure was the desire for an all-encompassing, intellectually elegant approach that also gave a chance for economists to show off their mathematical prowess, but it wasn't based on reality. And meanwhile, many economists, Heinrich and Gintis, I particularly like Gintis, showed that experimental economists often uncovered large and consistent deviations from their textbook representations of what's called homo economists. That means humans who are economic humans, who are supposed to be self-interested and even greedy and in the market, and to act accordingly. And literally hundreds of experiments in dozens of countries suggest that in addition to their own material payoffs, people have social preferences, that subjects in experiments that are done by people like Gintis care about fairness and reciprocity, and will give up money to make sure that the game is played fairly. They'd rather see the game, and the experimental game in which they are put, they will actually give up significant amounts of money in order to make sure that the game is played fairly, and to punish those who do not play fairly. This is completely at odds with what economists assume. Okay, the antidote, biophysical economics. I represent a loose group of perhaps several hundred scientists and economists who believe that we need a very different approach to economists. And if you want to go look at this, I will try to send this link out, but here it is, Biophysical Economic Institute and it only takes 10 minutes to look at it and explains it pretty well. You talk to the average person and you ask, what does economics mean to you? And they won't give you the answer the economist gives. They'll say, well, it's food on the table, a roof over my head, perhaps a car in the garage, or access to transportation. These are material things. They're stuff, and they have to be studied using the science of stuff, which is natural science. So why should economics be taught only as a social science? So what we need is a secure biophysical foundation that is consistent with and reinforced by what students are learning in the physical and life sciences. And so what is biophysical and economics? We focus, as I just have, on the internal logical and empirical inconsistencies of the basic neoclassical model, and the impenetrable jargon and mathematics. And we ask a really simple question. What is economics? Economics is the study of the use of fossil energy to exploit the Earth's raw materials and to transform them into what we want. And this is consistent with somebody asked me earlier about Polanyi, his approach, an anthropologist's approach. So I agree with that. And so one of the most important things is to stop thinking about money as money. If money is a lien on energy, each dollar allows you to access about 5 megajoules of work, i.e. half a coffee cup's worth of oil. That's what money is. It gives you access to energy. Now, this is the standard economist view of how the US economy worked. This was 1990. They had an input of per person of $3,000 of capital and $2,000 of labor to produce $23,000 of GDP. That's it. This is what they have. This is what the input is. The only input is capital and labor. The only output is GDP. Now, here's how a biophysical economist looks at the same thing. Well, you put in, for each person in 1990, it's more now, you put in 2,500 kilograms of oil, 3,000 of coal, 2,000 of gas, biomass, and so forth, and water and wood and brick. And this is kilograms. This huge amounts per person per year. And the output would be 89,000 kilograms of CO2, 29 of particulate pollutions, 84 of sulfur pollutions, 80 of nitrogen, and all kinds of other stuff. That's to generate the GDP of 23,000 required all of these biophysical inputs. This is why the conventional role of the economy that is used and taught in every economics department in the United States is a lie, because it doesn't consider this. Okay, what is wealth and where does it come from? Well, some people think money should be backed by gold. Well, let's think about it. When in the 1500s, the Spaniards doubled the quantity of gold in the old world, they halved its value. In other words, the wealth came from the energy that was used there, from the sun, rain, and wind, and from the activity of foresters, fishermen, farmers, housewives, artisans who did the physical work to generate the wealth. And the gold was like, doubling the gold was only like printing twice as much money. The backing of the money was the work that was done in society to produce goods and services. It's very simple. Now, why? For every person who wants environmental constraints, there are 100, who knows, who want to grow the economy. And how do you grow the economy? Well, use more energy. And it goes way back. The Wilsons here are evolving, socially involving, with a spear point, as we talked about, as an energy concentrating device. And fire, of course, allows us to eat more food and agriculture. Technology, most technology is about using more or higher quality energy. And the higher quality means electricity versus coal, for example, is higher quality energy. And you look at all the economic activity for all the countries of the world, and you see a roughly linear relation. This is the GDP of all these different countries. Here's some poorer countries, and here are some richer countries. And I don't know how to move this block, but the United States is, and a few other countries are up near the top. And how do you get richer? You use more energy. That's simple. So remember this? This is the economist view of how the economy works. It's just firms and households, nothing else. No inputs, no energy, nothing. So I'm going to show you how real economies work, and this is the basic biophysical model. You got to think about how economies really work, and it starts from the sources of energy for the economy. That's the sun, geophysical, and nuclear. The raw materials of the earth, ecosystems, and that includes a hydrological cycle. The hydrological cycle is probably the most important part of our economy, the proper functioning of the hydrological cycle, or let's say the median operation of the hydrological cycle. And in the past, in the operation of natural ecosystems here, represented by trees and deer, which in the past put down energy and matter as fossil fuels and mineral deposits. And along comes humans. And their first step is exploitation. So with a chainsaw, they cut down the forest and they grow crops, or they graze their animals, they build a dam, they make oil wells to exploit the fossil fuels, and they dig up all kinds of materials, copper, for example, and all kinds of other things to run the economy. Processing, a butcher block, a sawmill, an oil refinery, a electrical thermal plant, the steel making, manufacturing, all kinds of things in factories and in our agro processing industries, and then consumption. And this is all that the conventional economic model deals with, the relation between firms that generate the final product and our consumers. It's crazy. And of course, everything ends up as waste heat going up with this arrow here and in the trash pile. And what we have is energy and matter going along with the fossil materials and the materials throughout all this process and eventually ending up in the dump and as waste heat. And you can't use energy twice because of the second law of thermodynamics. Now, that is what I consider to be the minimum diagram of what an economy is, not just crazy firms and household things. This is what an economy really is, and it's the basis of our biophysical economics thought. It's that simple. Is a color version of the same thing. A little bit out of focus, I guess. The growth of the world oil supply is declining. So is the GDP. This is secular stagnation, especially in Europe, but also the United States. We don't grow as much as we used to. People are unhappy about that. Inflation is greater than it used to be. Okay, what about efficiency? Well, we have become somewhat more efficient in turning into GDP, or maybe. And I'm not going to go into this, but it's a long argument about how you correct for inflation. Because if you don't correct properly for inflation, then it looks like we're becoming a lot more efficient than, in fact, we are. And if you choose other ways of evaluating inflation, such as by shadow statistics, you get quite a different answer. Here is secular stagnation. The growth of all Europe, US, and Japan has greatly declined. Well, the growth of oil has declined. And why is the growth of oil declined? We've used up all the good stuff. We've found all the good oil. So all of these things cannot be explained by conventional economics, but can be easily explained by biophysical economics. And for example, labor productivity, which is somehow some sense of technology or how hard the workers work. No, it's just how much fuel is used per worker per hour. And most of the increase in labor productivity, at least over this time period, this is our work published in 1984, was that labor productivity was almost perfectly explained by the increase of fuel use per worker hour. We gave workers bigger muscles. They could do more work per hour by using electric motors and gasoline engines and tractors and so forth. So the Cobb-Douglas production function, the Solow residual, which Solow assigned to innovation. He thought the reason that wealth increased more than capital or labor was due to innovation, but it's energy. And when my friend Rainer Kummel examined this for Japan and put energy into the equation, the Solow residual disappeared. Carl will take your question when we're done, which I almost am, in Germany and the United States. So the limits to growth model made these predictions back in 1970. And you can see that the birth rate and the death rate and the population growth were modeled pretty well. Food per capita, industrial output per capita, and resource decline and pollution increase are modeled pretty well by that limits to growth model that I talked about last time. So I think the economists don't know what they're talking about. So most of our economic and financial theories were derived as our use of oil was increasing. Now we're kind of steady, bumping around, and a lot of economic models are having problems. Now, the amount of oil in the future is certainly going to decline. What economic theories are appropriate here? Think about it. We don't have proper economics for that time. Okay, so in conclusion, I hope to have shown you that real economies need to be studied as biophysical systems using quantitative natural sciences. The evolution of human society has been mostly about sequestering and using more energy. Fossil fuels, and especially oil, are the main reasons that human numbers and economies have grown. Human societies cannot possibly be sustainable at anything like our present level without a large flow of cheap, i.e. high energy return on investment energy, that the availability of oil in the immediate future is of considerable concern, that this may be our greatest issue related to sustainability of humans and civilization. And as far as I know, only myself and a limited number of others, and almost no economists, I don't know, or people around, are discussing sustainably think in this way. So, where are we in economics? We're stuck in a hodgepodge of these economic concepts accentuated by political, I can't read it here, oddities and enthusiasms. President Biden is essentially a neo-Keynesian with his rebuilding American infrastructure. You can only do that while you've got oil. The Federal Reserve is attempting to tamp down some of the resultant inflation. And we are left with a legacy of Reagan Bush past tax cuts, which causes our deficit. The deficit is not because of, well, it's due to a lot of things, but mostly due to the tax cuts of the past, which allow the 1% to become richer and richer and richer. It's very obvious. Okay, Keynes said practical men who believe themselves to be quite exempt from any intellectual influence are usually the slaves of some defunct economists. Madmen in authority who hear voices in the air distilling their frenzy from some academic scribbler of a few years back. So here we are. This was pre-industrial in the level of humans, how many humans there were. And here's our caveman ancestors with a spear and I guess a bone. And here's contemporary fossil fuel pulse. And if you look at 3,000 years in the future, here's our ancestors going along, and what they have from this period is a bow and arrow. Is that true or not? It's kind of tongue in cheek, but who knows? And there are many resources out there to help you think about this in depth. I certainly would emphasize our book about this, written by myself and an economic historian, and questions. And here is my final professional goal: to push this edifice of neoclassical economics, which is tottering at the brink of the precipice, to push it off. Okay, I am done today's lecture. I may show you two more slides, but let's take the question. Carl, you had a question.
Yeah, I just a question about that slide that showed the processes from the sun on the left to the
Yeah.
various intermediate stages and going off to the right. It reminds me of a similar, but I think in some ways more illuminating graphic in Herman Daly's textbook on ecological economics.
He has a simpler one from which I devised this. That's
And
true.
and what I liked about his picture is he showed the the classical economic description where it's got your circle diagram of inputs and outputs, and it's all money and labor. That's the classical view. With nature,
Neoclassical.
neoclassical, with nature as a subset of that of the economy, right?
That's how economists view it.
And
Nature
they
is a subset
and
of the economy, right?
right, nature as a subset of the economy, and that it was an open system, so we could keep there were no constraints basically to the
Right.
continuous growth.
That's
And
Herman
then
Daly's view.
and then
Herman Daly's view of conventional economics.
conventional economics. And then he
Right.
showed a view of what I think is your economics, biophysical economics, which has nature uh, as the system, the, and then the human economy is a subset of that larger system.
Absolutely.
But it's a
Human,
closed, but it's a closed system, so
right.
that all of that
Except for the
waste,
sun, except for the sun.
except for the sun, right.
Right.
But all of the waste products get dumped into this closed system, which means that all those wastes accumulate and
they come back to bite us.
they come back to bite us. And so that would be my one comment, is to emphasize that it's like running a heat engine in a closed system. What happens
Yeah.
when you run your car in your garage, right? Eventually the engine stops because it's running
Used
on
up the
fumes.
oxygen, used up the
It's
gasoline.
used up all the oxygen. And the temperature goes up, and eventually there's no temperature differential, and there's no clean air. There's no not. In other words, and this is another fault I have with classical economics,
Neoclassical.
neoclassical,
Yeah, okay.
and that is the lack of due recognition to constraints, resource constraints. I think that's one of the big things of your bringing resources into the picture, is there is such a thing as these are all finite resources. And
Well, I'm gonna
neoclassical economics has a real problem with anything finite, because it depends on the assumptions of indefinite growth,
correct.
infinite growth, and the idea of infinite growth on a finite planet is anathema to most economists. They just don't want to go there. Anyway, that's my
They don't want to go to the constraints. Yeah.
yes.
Herman Daly is one of my great heroes. I knew him well. And I've just sent you my piece about him, which is consistent with all of this. And what you say, I think, is right on. I guess you understand. Now, anybody want to speak? I'd like to have some more questions, and you would need to unmute your what do you call it, microphone, in order to get. And if you want to show yourself, a picture of yourself, that's good too. So somebody must have a question.
Well, I'm just thinking about behavioral economics with this, and
Yeah.
that's a place where the economists are sort of having to face reality that the
Yes.
theory about this rational human doesn't pan out very well.
And I really, I had a couple of slides, or one in particular, on that, and the experiments that were done by, what was his name? I just said
Thaler.
it.
Richard
Huh?
Thaler. Richard.
Well, for
Thaler.
example,
Yeah.
and they do all kinds of experiments that show that people don't behave as the economists must assume for their mathematics to work.
Mm-hmm.
Absolutely, Marianne. So, yep. Is this something you've studied yourself a bit?
No, I've not officially. I mean, not in an academic setting.
Well, I don't know how they get away with it. Quite frankly, to me, conventional economics is a house of cards, totally unsupportable. And how do they respond to this? I mean, I have been asked on two separate occasions to speak at departments of economics, once at Cornell and once at Wesleyan. And the economists could not refute what I said. In fact, they tended to agree with me. But it doesn't make any difference to them, because then they go on doing the same old thing. And mostly, well, it was very unusual for them to pay any attention to what I or my colleagues say. It just doesn't. It's an uncrackable edifice.
Well, I think if you were to do an economic analysis of economics, the field of economics, you will discover that the practitioners go where the money is. And that's
There's a great
crucial
quote from Mention. Mention, the the old Midwest philosopher, newspaper guy of 50 years ago, who said, never expect anybody to argue against an idea that supplies his paycheck.
Yes. And economists, I think, are not pure academicians. Economists have, in their utility function, this is now economic speak, we all have certain aspects of the world that animate us, that excite our interest and our pursuits, our pursuits in the quest for happiness, right? Well, I think economists have an unusually high desire for power in their utility function. They want a seat at the table. They want to be influential. And to be influential, you have to be deferential to those who have the power and who have extra seats at the table. You do not get a seat at the table unless you are trusted to say what those in power want you to say.
Well,
And
also,
most of the power,
economics supports this massive unequal distribution of wealth.
yeah, right.
And many economists are lining up on that side of the fence. Well, economists politically are all over the place, so there's no simple answer there. But
Right.
Has anybody else got a question? I'd like to hear from anybody else. And let's see. Is there nobody raising their hand or whatever? Well, if nobody's going to say anything else, I've got one more thing to show you. I would like to show you what is scaring the dickens out of me right now. So I'm going to share my screen again. I'm going to get out of where I am, if I can. Hello. Seems to me, let's see, yeah, the end. Just a second, how do I get out of here? Escape. And let's get out of here. And let's go to I had a couple of they don't see. Well, okay, I'll tell you what I had open and which I can't find right now. And that was concerning me. Let's see. Got to get back to the meeting. I assume everybody's there. I don't hear anybody. Eric, are you there?
Yes.
Okay.
We're seeing everything on your screen right now. You're seeing a bird.
Yeah, with all kinds of stuff. Well, we'll just have to deal with all kinds of junk up here because one thing I had, you can see me, right?
Yeah.
Yes.
One thing I had was how much oil was left by the different countries in the world. And there were a series of bars, starting with Venezuela over here, which has a lot of very poor quality oil sands. I'm not going to include that, but Saudi Arabia, Iraq, Iran, and then going down quite a bit was Russia. And then with about a third of what Russia was the United States. That the reserves that we have are only about a third of Russia and about a tenth of Iran, countries that we are obviously not necessarily in the best of terms with. And so one thing that we have to realize is that the oil that's ours, that's the United States, will be gone fairly soon compared to many other countries. And the other second picture that I wanted to show you what was how much natural gas we had. And that's arguable, but Jean Larrey has some analyses, and he's pretty good, I think. Jean Larrey has some analyses that indicate that we have only about that will have peak gas about 2025 or so. And then it will drop off very rapidly because all the gas that we're producing now is coming out of this fracking. And most of the fracking has been done in the sweet spots. If we didn't have fracking for gas, we'd be in deep, deep trouble for both oil and for gas. So the thing that was bothering me was not simply how much energy we had left for the oil for the world, but how much we had left for the United States. And I had a rather rare and unexpected burst of nationalism or national concern about my own country, that it might be that within a decade or so, the United States might find itself in a very different situations, because the power that we've had since World War II, or since the beginning of World War II, has been due to the incredible exploitation of oil and gas and coal. And we still have lots of coal. So, are we going to go back to coal if we have to? Can we build? Do we have enough energy to build enough photo cells and wind turbines to, in any sense, replace the oil and gas that we're likely to lose? Because not only do we have lower reserves, we have about 3% of the world's remaining oil. Where a country like Iran has maybe 15% or even 20%. What happens if the future strength of nations is dependent upon how much oil they have? And it's not just that our reserves are less, is that we're going through them so much faster. We're using them up faster than any other country. So, so maybe we're doing Iran, for example, a favor by trying to constrain how much they pump out their oil wells and sell them on the world, because in 20 years, they'll have a lot more oil than we will. And what does that mean?
Do you mind a comment from
Sure, go ahead, anybody.
on your concern? So just as you complained about economists not including energy as a variable in their production function, I think maybe adding some additional variables to the production function besides labor, capital, and energy might help give us some clues as to what the future holds. And I think Solo's idea that innovation or actually information is an additional input may suggest that innovations can the I in that production function can substitute for the E in that equation. More
Well,
information, more innovation, and particularly with respect to alternative energy, could be the answer to the constraint due to the finiteness of the energy resource.
Well, Carl, first of all, that solar residual, which disappears when you add energy, that would imply, wouldn't it, that all of innovation was innovation to use more energy?
Well, it's innovation, yeah, and innovation to make our other products more efficient with lower energy inputs.
Except we can't.
So,
That doesn't happen because of depletion. So fish take more energy to catch when we've depleted the fisheries. Copper takes more energy to refine, and then maybe you can make something with it more efficiently. But to get the copper, you have to grind up 10 times more ore and so forth and so on. So I think,
right, but then
do we have pure innovation?
but then there,
think
right, but then there are efficiencies in, say, recycling existing copper, and so on and so forth. I don't want to, I mean, I'm just saying the ingenuity of overcoming un, in unforeseen ways, unpredictable ways, obstacles that we thought before were insuperable become superable, and so I'm just saying that it's not all doom and gloom, I don't think.
I would not say my view is, I don't talk about doom and gloom, but I do talk about difficulties of, let's say, the transition. And, if you look at the materials requirement as Inicio Capellan Perez has done in Spain, the energy cost of moving to renewables is very, very high.
True, true. And I wish we looked at all of those kinds of issues much more closely than we do.
Me too.
It's so hard to get any kind of yeah, anyway, I agree with you that
Absolutely.
uh there is a, you know, in fact there was this great book in the 80s or 70s and I forget the author's name. You might remember it, called uh, Entropy Watersheds or something like that. And anyway, he talked about uh, how each stage of history, from first we were uh, 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 burning wood, then we were burning coal, then we're burning oil, and then and he would say that these were entropy discontinuities. That's how he called it. But he then went on to say uh, there were limitations to our ability to convert to solar because of those precise inefficiencies that limited every other stage of history, namely that we create so much more waste and use so much more energy with each of these stages. And so, like with solar, are we actually going to be able to manage a transition to solar without creating so much more uh, ecological damage in so many different ways that
Well, we're certainly going to
becomes,
dig up a lot of the earth to get the copper and the lithium.
yeah. How much ecological damage is caused by trying to get to that next level where we become more independent of
But I have
fossil
seen
fuels?
an analysis that the amount of earth surface that we would have to disturb to get the lithium is much less than what we disturb to get the fossil energy. So I don't know. Somebody has
Yeah.
done that assessment and came out favorably towards the renewables, but I can't give you a quotation on that.
The sad thing is we're just making assumptions that if everybody just owned EVs, we'd be better off. Well, do we really know that that kind of massive shift from one set of technologies and resource inputs to another set of technologies and resource inputs and being able to sustain that?
May I
We're-
recommend to you call a book by Alice Friedemann. It's called When
Okay.
Trucks Stop Running. You love it.
Okay. All right.
It's easy. It's an easy read. It's
I'll write
lots of
that
fun.
down.
Okay, Alice Friedemann.
Is that fiction or nonfiction?
It's nonfiction. It's by Springer.
Okay.
In a series I edit. When Trucks Stop Running. But
Okay.
she's a delightful. She's lots of fun to read, and
I'll get it.
she has a
Thank
new
you.
book too. I don't remember the name, but it's
When did this come out?
about 8 years ago, I'd say.
Okay. Uh-huh.
And it talks about the difficulty of trying to figure out some kind of electric transportation of
Yeah. Yeah.
goods. I mean, Route 5 out here. Can you run Route 5 on electricity? I don't think so.
Yeah. Well, I'd like to
I
see.
wanted to make a point about economics. Since I got 2 minutes left here, which is this: the physiocrats back in 1750. When you ask about the source of wealth, the physiocrats said it was the land. In 1850, the classical economists would say labor. And in 1950s, many of the neoclassical economists would say it's capital. But all of them actually are talking about the major sources of energy for their time. So that land intercepting sunlight was a major source of energy when most wealth was derived from trees, from crops, and occasionally digging out minerals. So they thought land was the source of wealth. When you concentrated people's muscles into factories at the time of Adam Smith to Karl Marx, labor was the source of energy. And, labor is restructuring the materials of nature into the things that humans want, cotton into shirts and so forth. And then capital, you may not think about this about capital, but most capital is the means of using fossil energy. So each of them is in fact reflecting the energy realities of their time. But they were not viewed from an energy perspective, although, Marx understood to some degree energy. But he's in his letters, but not in his books. So I think that's kind of interesting to think about it that way. So we would like to think that we can use biophysical economics to understand conventional economics better.
Mm-hmm.
Okay, any final questions? Enrico, any questions from Italy?
No, Professor.
Okay, you learning anything? Okay,
Yes.
good. Well, we have one more lecture and then the course is over. Thank you very much, Eric.